Today we are still working in the first set of notes, and we're going to go back to that table that has all the properties on it that we talked about yesterday. We are going to be focusing on or filling in the rest of the chart, so all the rules that are empty we're going to fill in. So first rule we're going to pick up with is the second one down from the top. So it says a to the nth power raised to the nth power. So this is what we call when we have a power raised to a power. And when I have a power raised to a power, we multiply our exponents. So here we have 5 to the 1/2 times 4, and this can be thought of as like a 4 over 1. And that means I have 5 to the 4 over 2. And 4 divided by 2 can be simplified to 5 squared. So our final answer would be 25. So that is the first rule that we're going to talk about. So the next rule is very similar to that one. I think we actually talked about that one in the last video, but this rule is very similar. Here we have the product of A and B. Notice A and B are different bases. So I'm going to have two different bases in parentheses, and the whole thing is raised to the power of m. And when that happens, it's the same thing as saying A raised to the nth power and B raised to the nth power. So the example for this one, we have 4 times 5 raised to the 1/2 power. So if I go in the parentheses, it's implied that 4 is raised to the first power, and so is 5. So essentially, I'm distributing this 1/2 to their exponents. So now this will be 4 to the 1/2 power times 5 to the 1/2 power. And whenever you write your final answer, I want you to put it back in radical form. So if I did that, going back to what we talked about on Friday, remember the bottom number of the fraction always goes outside the root. So this is technically the square root of 4 to the first power, and this is the square root of 5 to the first power. And I can take the square root of 4, but we can't take the square root of 5. So the square root of 4 is 2, and the root 5 just stays part of the problem. So that would be the next rule. This rule is an important rule. We're going to do a lot of practice on this one because this one tends to be a more difficult one. Notice my power is raised to a negative value, and when it's raised to the negative value, that whole term moves to the bottom of the fraction, and now it becomes positive. So, and I had a question in my other class as to why there's a 1 on top. Technically, this is a 1a raised to the negative nth power. So the a to the nth moves to the bottom, but the 1 still stays there, and that's why there's a 1 on top. So the example for this one was 9 to the negative 1/2 power. So if I applied the rule, the 9 to the 1/2 power moves to the bottom of the fraction, and now notice that the 1/2 power is positive. Putting it back in radical form, this is 1 over the square root of 9, and then the square root of 9 is 3. So my final answer would be 1 over 3. Notice I keep that 1 over the whole way through the problem. And the last rule is very similar to the second rule I talked about, where you have two different bases inside this parenthesis, and we're going to distribute this power to both of the bases. So here I have 5 over 27 raised to the 1/3 power. So essentially it just means 5 gets raised to the 1/3 power, and so does 27. Now, common mistake is that students will look at this problem and think, oh, well, I'm dividing, so therefore I can subtract my exponents. But however, my bases are not the same, so I cannot do that rule. You have to have the same bases in order to subtract your exponents. So we're going to go back to putting it in radical form. So this is the cube root of 5 over the cube root of 27. And one of these can simplify further. Cube root of 27 is 3. So my final answer will be the cube root of 5 all over 3. And that would be our final answer for that one. So now that at that point, that whole table at the top of your page should be completely filled out. So now we're going to do that set of examples. There's 4 problems at the bottom of the page. So we're going to do those, and then we'll end the video for there. So for your first example, we have the 4th root of x cubed divided by the 8th root of x squared. And the first problem that arises is that right now we're in radical form, and all the rules above in the chart are all talking about exponents. So I need to get rid of these radical forms and put it into what we call exponential form. So if I do that, we are at x raised to the 4/3 power, or no, x to the 3/4 power, sorry, all over x to the 2/8 power. And when I look at these two fractions, one of them can reduce further. My 2/8 can reduce further. So let me go up here. So I have x to the 3/4 all over x to the 1/4. So 2 divided by 8 can reduce to be 1/4. And now I have the same base, and I'm dividing. So that means I subtract my exponents. So this is like saying x to the 3/4 minus 1/4. And I have common denominators, so I can subtract the top. So I will get x to the 2/4, which can reduce to be x to the 1/2. And if we put our final answer back in radical form, we get the square root of x. Again, because there's implied to be a 2 there, and the first power here. So that is our final answer for that problem. So again, to recap, if it's in radical form, you got to get it into exponential form, then apply the rules. So same thing in letter B. They're both in radical form. I need to get them out of radical form. It's implied to be a 2 here and a first power there. This is the 4th root of y to the first power. So I can rewrite this first one as y to the 1/2 power. Operation between these two is multiplication. And then I have y to the 1/4 power. So multiplying my bases, so that means I add my exponents. So I'm dealing with y to the 1/2 power plus 1/4 power. And when I go to add, I need to have common denominator. So when I look at these fractions, my common denominator would be 4. So I need to multiply this 1/2 power by a 2. So that's going to change that fraction to become y to the 2/4 plus a 1/4. Now I have common denominators, so this is y to the 3/4. And I always want you to put your answers back in radical form, so this means it's the 4th root of y cubed. So that was letter B. Letter C is already in exponential form because it has an exponent. The problem is it's a decimal, not a fraction. So if you have a calculator, you would start dividing different numbers, see if you could obtain a 2.5. If you had a TI calculator, like the big ones that we use in the classroom, you would type -2.5 and hit math fraction, and it'll give you the fraction. Easiest way to think about this is, well, I know 4 divided by 2 is 2, and 6 divided by 2 is 3. So 2.5 is exactly halfway between those, so that means this fraction is a 5/2. So this is the same thing as saying 16 raised to the -5/2. And now we have to apply that rule with the negative. So the negative says the whole fraction, this whole term, moves to the bottom of the fraction. So now it is 1/16 raised to the +5/2 power. So notice by moving it down, we drop the negative. Now we're going to put it back in radical form. So this is 1/the square root of 16 to the 5th power. And the other day in class we talked about, you have two options. I could raise 16 to the 5th power and get that large number and then take the square root of it. Or we could do the other way around. So we can take the square root of 16, and the square root of 16 would be 4, but I still have to raise it to the 5th power. So then we would have to raise that to the 5th power, so we have 1/1024. And that would be our final answer for letter C. So last one, letter B. So notice my exponent's not negative, it's the base that's negative. So I can't move it anywhere. I'm just going to put it back in radical form. So this is the 5th root of a -32 raised to the 4th power. And the cube root, or the 5th root of -32, so you think what times what times what times what times what would give me a -32. So that actually is a negative 2. So the fifth root of negative 32 is a negative 2. But then I still have to raise that to the fourth power. So if I do negative 2 times negative 2 times negative 2 times negative 2, we get a positive 16. So there is our final answer for that problem. Okay, that's all for today.